Rational expression equations. We've already discussed proportions in a previous video where you have a fraction equal to another fraction and you could cross multiply to solve. For rational expression equations, there are a couple of different methods, but the method I think is the best and easiest to remember is to essentially turn it into a proportion. What we mean by that is we have to the left of the equal sign an expression, x over 2 plus x over 3. We can combine that into a single fraction by adding fractions, and we'll need a common denominator to do so, but we can combine that to a single fraction and then set it equal to the right side, which is a single term, which we can put over 1, so that's a fraction. But if that side was more complicated, we could also combine that to a single term, and then it's a proportion cross multiply. So that's what we're going to do. So let's focus on the left. The x over 2 plus x over 3. The common denominator would be 6. So we're going to multiply the left by 3 over 3 and the right by 2 over 2, which will get us 3x over 6 plus 2x over 6. And now that I have a common denominator, I can combine them to a single fraction, and the numerators are being added together, 3x plus 2x, and they are like terms, so that's 5x over 6 equals 5 over 1. Now it is a proportion, and we could just use our cross multiplication. 5x times 1 is 5x, 6 times 5 is 30, and then dividing both sides will solve for the variable 6. The second example is the same thing. I'm going to combine the left side into a single fraction by just adding and subtracting in fractions, getting common denominators. The common denominator between x and 5 is going to be 5x. And so I'll multiply the left by 5 over 5. Remember what you do to the top, do to the bottom. The right by x over x. And so that will ultimately give you 10 over 5x plus x over 5x. Now I'm adding the numerators, but 10 and 1x are not like terms, so I can only leave it 10 plus x over 5x. I can't add or subtract unlike terms. And that's going to equal 12 over 5x, which is already a single fraction. Now it is a proportion. So we cross multiply. 5x times 10 plus x. Now 10 plus x is a polynomial, so you have to do a little bit of distribution. 5x times 10 is 50x, and 5x times x is 5x squared. And that equals to 12 times 5x, which is 60x. All right, now at this point, because of the x squared, this is turning into a quadratic type of term, which you'll have more videos focused on later on, but I will finish this problem because the x squared, I can, kind of get everything to one side and organize it. The best thing to do here would be to subtract 60x to both sides, and I'm going to put the 5x squared in front, so my highest exponent is leading, and minusing 60x, I'll get negative 10x equals 0, and from here I can factor out a 5x and get an x minus 2 equals 0, and set each factor equal to 0. 5x equals 0, I end up with x equals 0. Dividing both sides by 5, 0 divided by 5 is still 0. And x minus 2 equals 0, end up with x equals positive 2. Now, looking back at my original, it probably should have said somewhere over here that x cannot equal 0, because if it did, these terms down here would be undefined. So I would actually kind of reject that solution and just focus on the positive 2 solution. But this is when we get in more into quadratics. The basic rational expressions are more like the first example, where you can get a single fraction on the left, a single fraction on the right, turns into a proportion, cross multiply, and solve.